now. Okay.
We're live.
All right. Welcome everyone to the Radix AMA about the Cerberus white paper. We've collected a load of questions on Reddit and a few other forums, which I've already added to the column on the right-hand side where you can see where the Q&A. If there's anything you particularly want answered to get ahead of the order that's already here, if you just click upvote, it will move the questions upwards. You can also ask your own questions by submitting a question in the box at the bottom right, so that you can ask any extra questions or follow-up questions. This really is a forum for you just to get some more clarity on some things that you want to know. So without further ado, I am going to pass this over to Dan so he can start going through the questions that we've got.
Okay, cool. So first one is, when is the next white paper coming out? So that would be the updated economics. What revision are we on now? 10?
I think this is the internal version 7, external version 3.
Yeah, so obviously with proof of stake for the RPN networks, we've had to modify some of the economics, mainly around emissions. So that's been drafted. It's been through a few drafts already, so that should be due when? Any idea, Piers?
We don't have a set date, but it's going to be pretty soon. The changes are relatively minor. Essentially the addition of an emission and a couple of other things that we've had to sort of move around, but I don't expect any major surprises in there.
Yeah, and things like staking as well, some mods for that, and a few other bits and pieces. So yeah, like not a massive change to the baseline economics. It's just more just bolting on some of the stuff that we need to have to support proof of stake for the RPN networks.
Yeah, cool. I'm going to mark that as answered. How does Cerberus balance liveness and safety? What do you think is more important for a secure network? Great question.
Oh, that's an interesting question. Also, potentially a loaded question too. So Cerberus being a multi-decree consensus mechanism, generally, if the network gets into a particular state, then it will, where there's maybe an attack going on and things like that, then it prioritizes safety over liveness, so that you can't roll back transactions and that kind of stuff. Whereas Bitcoin, for example, and blockchains tend to prioritize liveness over safety. Hence, proof of work is what is your safety guard. And I mean, it depends what your network is built to do. There's no right or wrong answer here. It's just that in kind of multi-decree stuff, safety is generally prioritized over liveness, and in probabilistic networks with maybe single decree stuff, then liveness is usually prioritized over safety. And there are pros and cons to them both. So it's just a matter of looking at what it is you're trying to do, what you're trying to get out of the network, and just trading off between those two things, depending on your architecture and what it is you want to do. But yeah, Cerberus prioritizes safety over liveness.
And what do you think the importance for security is in prioritizing safety over liveness?
So again, it's there's no real kind of definitive answer for that. It really does depend on what you're trying to achieve, what your network looks like, where are your safety bounds in terms of your Sybil and all that kind of stuff. Obviously, a secure network is paramount, whatever you're doing. But prioritizing safety over liveness does give some nice advantages where an attacker can't just arbitrarily pick a moment in time and then do a deep reorg of all the ledger history based on what he wants to have happened, which you can do in Bitcoin because it priorities liveness and your proof of work is your safety basically. But then the trade-off is, while if you do have two kind of deep partitions that are separated for a long period of time, then the longer they're separated, the more difficult it is to merge them back together. Whereas with something that prioritizes liveness and is more probabilistic in the way that it drives things, you can usually merge those things in some way so that you don't have a kind of persistent fork. But again, there's no right answer. It just depends what you want the network to do, what your requirements are. So yeah, again, this is the easiest route as well for us to get to an RPM1 to preserve safety, because then we don't have to think about merges and having a lot of partition tolerance and stuff as well.
Cool. What is the patent situation, and how will they work with open source?
Yeah, this seems to come up a lot actually. People asking about patents and open source. Like you can have a patent and you can have an open source project as well. It just depends how you construct the licensing around your open source. So we can have a patent on technology and an open source platform, but with some kind of restrictions on what somebody can use it for, right? So if they're using it for a particular purpose and they're building from the Radix code base, that's fine. But if somebody builds basically Cerberus or Tempo or anything else that we have a patent on without using our code base, then they would then infringe the patent. So I mean, the patent just gives you the right to sue, basically, if someone takes what you have and builds it into their own thing and passes it off as their own innovation. How you manage that is very flexible and very open. So there's no problem being open source with the patent.
Cool. What are some of the key milestones on the road to RPN1? We have on our GitHub, we actually have, on our knowledge base, we actually have the consensus roadmap, which has the basic milestones. I'm just going to add this to the Q&A so that people can see it. If you look in your Q&A answered tabs, you'll see I've answered to Nikki with a direct link to a document. But Dan, if you want to just talk through some of the sort of high-level milestones that are important for to get to RPM1.
Yeah, so at the moment we're working on building the kind of foundational guts of Cerberus, and at the moment we're just building all of that logic and all of the components that drive the event coordinator. You know, nodes need to be coordinated in, and when do they vote, when do they do certain things, when do they propose, when do they commit, and all this kind of stuff. So at the moment we're just working kind of local host, building all that kind of stuff. I believe now that Florian has started to move onto some of the other tasks where that then opens up to multi-node stuff. He's been doing quite a lot of work on some of that kind of boilerplate plumbing down at the kind of fundamental levels. And once we get to having Cerberus functioning in terms of multi-node, then we can start to do things like system testing and catching all of those kind of orchestration issues that we may see between nodes talking to each other and the leader proposing something and the nodes being able to vote on it and knowing when to vote and making sure that the vote is valid and that there's a supermajority and all kind of cool stuff that Cerberus needs to do. After that, we then need to start thinking about how do things like the global shard, where will the validator sets get registered, and how that all kind of comes into play. So that's probably one of the things that will come shortly after the multi-node stuff, along with then actually driving proof of stake and those kind of things. But we can chop that into kind of two tests. So we can run a global shard and have it very kind of KPI permission for our own internal development, so we don't have to be staking and all this kind of stuff to test out the fundamentals of the validator set selection and how those validators are used for particular events and stuff. And then step from there forward into kind of the proof of stake side of things, where then you are staking, destaking, and delegating and all that kind of stuff. And then further along those milestones after all that, there's things like the fees that we need to do. We need to build the emission stuff, and just kind of general kind of testing and integrating the Radix engine and tidying up any things that kind of happen. So we kind of have 2 to 3 major milestones first, which is all the kind of really heavy stuff: single node consensus, multi-node consensus, economics, emission staking, validator set. And then from there on out, it's more around most of the more peripheral stuff, like your networking layer and your API layer, and how the Radix engine kind of integrates all of that stuff and any additional features that we need there and those kind of things. So yeah, it's generally split up into about 4 large milestones for RPM1.
Cool. Is the view number mentioned in the Cerberus white paper a sort of logical clock?
Yeah, it is, but it isn't, but it is at the same time. It's like if you take the strict definition of what a logical clock is, then it is. But it's a different kind of logical clock than what most guys that know Radix for is in Tempo, right? So in Tempo, the logical clocks were kind of local clocks that each node would run and strictly increment every time they saw something. Whereas in RPM1, it's more of a kind of global shared clock, as in the view number, everybody's aligning to the latest view number. And then when we move to sharded, those view numbers are more kind of emergent logical clocks. So you've got a particular event with some particular atoms, particular particles in particular shards, and each of those particles essentially has its own kind of view number or logical clock, if you like. So once we're in full sharded, the logical clocks are very short-lived and they're very ephemeral. So depending what definition you look at, then some may regard them as logical clocks, some may not. I personally do. You ask Florian, he'll tell you a different answer.
Cool. When can we expect an update on the leader denial of service resistance section of the Cerberus white paper?
Yeah, so actually got some a meeting tomorrow that may touch on some of this stuff. So all the kind of leader DOS stuff that ties in quite heavily with validator selection and all the global shard and how all that's managed. And there's a number of meetings that we need to have to kind of drill down in the granularity of what that looks like. We have some, broad strokes architecture of what the global shard will look like, but there are some little details that we need to get into a little bit more. But everybody's kind of had a lot of stuff to do with the first milestone, so it didn't seem sensible to disrupt that at the moment, especially as everybody's got quite good pace at the moment too. But we are getting to the point where some of those questions need to be answered. So that'll be a series of meetings over the next couple of weeks. So maybe if whoever asked that question asks it again at the next AMA, I can have a more definitive answer for you. Because at the moment, it'll just be floating ideas.
I suppose a follow-up question for myself is like how critical do you see leader DOS resistance being in sort of the first versions of the Radix network?
The first versions, yeah, I think as we move from RPM1 to RPM3, the difficulty of DOSing a leader becomes much more difficult. Because for RPM1, we've got to have a fairly small, quite tightly controlled validator set, just because of how RPM, what its mandate is. It's not sharded, it's not network sharded either. RPM2 will be potentially a little bit better because we do have multiple Cerberus instances then running on nodes, so you can potentially have a lot more nodes in the network serving these different instances. So your risk of DOS resistance there drops a bit more because you've got more nodes, and then you don't necessarily know who's going to be the next leader. And by the time you figure that out and DOS them, the event's probably confirmed. And so. And then once we get to full on sharded, then you've got to have a lot more information at your disposal, which you can do if you're a strong adversary, right? You can collect all this information, but then your window to act upon that information as we step through the different RPN networks just gets much smaller and much smaller. And you could if you're the one generating the event, then there's some tricks you can do, but really you're just DDoSing your own event then. So yeah, the risk reduces as we move through. So at the beginning, it's very much a fixed set, and those validators are mainly responsible for everything, and it's a fairly small number. But then as we can scale up and scale out, you'll have a lot more diversity around the leaders that are leading the consensus for a particular event, and you won't necessarily know who that leader is going to be either.
Cool. Is the plan to develop a Dan-based Sybil strategy in strategy? Is the plan to develop a Dan-based Sybil strategy in parallel with POS? And when it is time for RPN 3 to possibly switch to a Dan-based strategy? I think this is sort of talking about SMS, right?
Maybe, but it says Dan-based, so is that me going around with a big stick? I'm not sure. Assuming they're talking about SMS, yeah, people ask this a lot as well, right? I mean, POS is good enough for us for now. We've got a lot of work to do, and we're trying, and we want to get through this work as quickly as possible. Of course, I would like to move to a more novel Sybil mechanism based on all of the research and hard work that we did over the past 6 to 8 months. But it's certainly not very high up on the roadmap at the moment. There's still a lot of research to do there as well, and at the moment it's all hands on deck. And I and everybody else right now don't have a lot of spare time, and we're probably not going to get much spare time for the foreseeable future to kind of dig into this stuff. And even when we're there, you're probably looking at a good 6 months for SMS where it was left off, to dig back into that and bring it to maturity, really like battle test it, get peer review of it, get other sets of eyes on it to make sure that it's good. Because it is quite a novel twist, so it's not like we're building on much of anything that came before. We can't kind of bring along any of that knowledge or that kind of confidence that what we're bringing along, and what already exists in SMS is already tried and tested. There really isn't a lot in there that is tried and tested, so quite a lot of work there to get that to commercial grade. So
it's sort of a nice to have. It's a nice to have, right? But like in the battle for making sure that you are the protocol of choice for X, whatever X happens to be, whether or not it's DeFi or sort of non-government money or store of value, or whatever it happens to be, right? The Sybil protection mechanism often isn't the deciding factor at the moment.
Where a Dan-based Sybil strategy would come into play is if POS really centralizes. That's probably the main catalyst where you would think, right, okay, this has just got way too centralized. There's way too much control in the hands of the few. But that doesn't happen overnight either. I mean, proof of stake, aside from all of its kind of recursive issues that it has in terms of like difficulty in making it secure, from an efficiency point of view, you don't get much more efficient than what proof of stake does. There's some stake, you know who owns the stake, and you just shuffle that set based on some function and take n number of validators out of that, and they're your validators. And yeah, that's pretty trivial to do. From a consensus point of view, give me some validators, boom, there you go, real nice and easy, real quick. But proof of stake does centralize over time, so that would be the main reason I think in the future to actually switch out. If it ends up where you've just got 20 whales that are controlling the network, that definitely isn't ideal.
Cool. I saw in a roadmap that RPN1 will use blocks. Will these blocks form a usual blockchain data structure, or is it different?
Yeah, so I believe that was a little bit of an error in the paper. I don't think it's supposed to reference them as blocks as such. But we are having some discussions for RPN1 because of the reduced validator set size, where batching our events into something that may look like blocks would actually give us just make our lives a little bit easier. So this is kind of a pending question. Originally this was no, and then we had a discussion and it was still no, and then we did some analysis on throughput that we could achieve on RPN1, and it wasn't quite what we were aiming for. And batching these things into something that essentially resembles a block of stuff would push that throughput for RPN1 a bit higher. RPN2, because you're then moving into multiple instances, and you've got everything is kind of organized into the shards that it will be in, you can't really use blocks at that stage, so they would be more of a temporary stopgap.
If it was batched into blocks, would it look like a blockchain data architecture? So would those blocks subsequently be chained together, or would it look different?
So from the fundamental data architecture and the database on your node, it wouldn't be stored as a kind of blockchain as such. It would be more of a mapping, kind of an overlay mapping of this batch of things goes into this block, but on database and in kind of particle and shard space, they would be stored as if they went in blocks. It just means that you can reduce kind of message complexity and latency and stuff when you only have a small set of validators that we need for RPN1 to get it out the door. And so batching those things into essentially blocks from a kind of consensus and network point of view, in terms of transferring data and stuff and getting agreement on those things, it just helps us to push the throughput a little bit more. But from a kind of foundation serverless point of view, how things are managed, how the Radix engine manages things and stuff, then that would behave very much as RPN2 and RPN3. Well, it's just more of a kind of efficiency tweak that we need to do now. That's just short-lived for RPN1, because you can't batch things into blocks when you move to RPN2 and RPN3 anyway.
This is a question for me. What is the plan for marketing on Radix and creating some awareness and maybe some hype prior to the token sale? Yeah, I mean, these are marketing is a key part of our strategy in getting token distribution. One of the things that we constantly have choked on is timelines, because you can ramp up your marketing spend and then not actually be able to deliver on the timelines that you were aiming for delivery of technology that sort of goes alongside it. So we often put together strategies that involve a certain amount of marketing spend, either over the top or sort of content based, or working with sort of marketing partners, PR firms, all that kind of stuff. And we've tended to not actually sort of push the button on them. We're still assessing what the hell is going on with the markets at the moment with regards to COVID-19. But assuming that the static timeline, then yeah, we'll be ramping up some marketing spend. We're working with some partners already on PR. We're also sort of going to be rolling out an ambassador program, working with some of the top tier universities in America and then the rest of the world. We're obviously doing the R&D with UC Davies, which someone's already asked a question about, which is basically working with the leading PhDs and professors in the blockchain space on specifically the kind of consensus that we're working on, and having them come in and look at our technology and our solutions, and doing research on things like mathematical proofs and peer reviews and things like that, which obviously helps the reputation of the mechanics of what Radix has created to create this high scalability system in the first place. That all helps in terms of building a marketing message around the credibility of Radix and what we've created, and that will sort of flow into sort of the bigger marketing funnel. We've continued to build our mailing lists, and we've actually seen a fairly significant uptick over the last 2-3 months. On our mailing list, we've increased them by another sort of 15-20%. And so while you don't see so much in the paid marketing space, so sort of like coverage on click-through marketing and banner ads and stuff like that, we've actually significantly improving our numbers for direct marketing, and we continue to do that with our funnels. And we're going to be updating our website. That's going to be coming along end of this month, start of the next month. Much simpler click-through design, much more focused around sort of the upcoming token sale and all that kind of stuff. So that's all in process, and you'll start seeing some of the results of that alongside the updated token economics. When can we alpha test Cerberus related stuff?
So realistically, that's probably going to be after the second milestone, which is all the multi-node stuff. I mean, can't really test much unless you've got all that plumbing in place where nodes are actually talking to each other. No real timeline on that at the moment. It's still kind of moving around quite a bit depending on what progress we get one week to the next. So, but as soon as that's on the cards, then obviously I'll let all you guys know, because that helps us a lot with testing, and it means we don't burn as much to good old Amazon. It's a more real test as well, because Amazon and Google have their own dedicated fiber from continent to continent pretty much, and that's not really what we want to test. So yeah, we'll probably at some point after the second milestone, which is all the multi-node stuff, and we have the kind of global shard stuff figured out, then yeah, we'll at some point then be in a position where we can start to do alpha testing. So watch this space for that.
Cool. Any further questions, guys?
I guess not. That's all the questions answered in record time.
All the questions. Look at that. Cool. So please do keep asking questions on our Reddit forum or via Telegram. We will always do our best to sort of get back to them. Oh, Wingspan. Will some transactions be free?
Don't know yet. We need to look at the fee model a little bit more. The problem with free transactions is that then how do you spam prevent if they're free, right? And we had a bit of an internal discussion not long ago about using proof of work for that, but using proof of work as a spam prevention isn't great either, because depending on what hardware I'm using, then everybody's paying a different cost for their spam prevention. If I'm on an iPhone, then it can't do as many POWs as me if I'm a dedicated attacker and I want to screw around with the network and I GPUify my POW. I can do orders of magnitude more than the iPhone user can for orders of magnitude less money. So free transactions are a bit of an issue. I mean, it'd be nice to have them for some things, but yeah, it's something we need to revisit.
I think it's one of those things that's like, someone has to bear the cost at somewhere, and so you've really got to weigh whether or not adding free transactions to the system versus what are already very, very cost-effective transactions on Radix, right? Like, you're already starting at a very low, cheap base, and you can put quite a lot into an atom as well. So it's not like it's not just the fact that there's one thing in there. So like pushing it even lower.
I mean, it's like you were saying, who bears the cost, right? So if you have free transactions, then it's the node operators that bear the cost, because if somebody is spamming the network and your anti-spam mechanism isn't good enough, or it gets breached, then they essentially need to have machines that can keep up, which then makes the per node cost expensive, which means that your nodes, you get centralization of your nodes then, because the cost to entry gets higher because your cost of use goes down in terms of node operator. So, and we don't really want that either.
I think if there was a very clear reason for free transactions that drives the ecosystem, so there's two ways of looking at a network. One is I just want businesses to use the network, and the other is to look at it from the point of view of how does the ecosystem feed the ecosystem. So if you think about stuff on Ethereum where MakerDAO creates DAI, and then DAI then goes into other smart contracts like Compound, or how Synthetics is then traded on Uniswap. These things all feed each other. They all feed the ecosystem. And if there's something that you can say, oh look, if there's a flywheel, there's a flywheel here. If we can make this function cheaper, then it's actually going to drive more adoption in the ecosystem and more users to come in. That's a really good reason to think about essentially subsidizing a function on your network. But just going,
it's not blanket, right? And then you need some governance mechanisms to be able to then agree, investigate, determine which of those kind of features or applications or use cases are the ones that are driving that flywheel. So then it pushes the problem out to a different place for a solution there. So.
Okay. When beard shaving?
Oh, not yet. If you look at the hair, the hair's even worse. Look at this shit. I mean, I can almost get a really good mullet going on at the moment.
Yeah, you definitely can. I think you should shave the sides just to prove that you can,
just
you
for
can
a
do the
gag,
full mullet.
show everybody that I'm pretty sure Jess would not approve. Man, she doesn't approve at the moment.
I think you should shave the sides and then also shave the middle bits, so you've just got your nice big mutton chops and then like a nice goatee in the middle.
Ponytail that you had.
It was honestly the easiest haircut I've ever had in my life. It was so easy to maintain. You just shave the sides,
but it looked shit. So yeah.
It's beautiful. It made me happy. So that's all.
Is that all that matters? Is it? Okay, fair enough.
And it annoyed you, which also was like an extra bonus.
Yeah, it did. Quite a lot.
Who are going to run 100 or more nodes in RPN 1 and 2, and why is the number 100, and how is this minimum will be maintained?
Okay, so RPN 2 doesn't necessarily have to be 100, depending on how we're moving forward and what things we need to have in RPN 2 and what things go into RPN 2. We likely don't need to have such a strict constraint on the number of nodes that can be validated. So the idea for RPN 2 as well is that it does open up that validator set, so it does become much more decentralized than RPN 1. The reason we need to have a constrained validator set in RPN 1 is that RPN 1 is the simplest possible version of Cerberus, so that we can prove the tech and get to market, which means that it runs completely unsharded. So there are no shards. Well, there are shards from the data level, but from the kind of operations level, all nodes are essentially serving all shards, and there's no way to kind of configure that in RPN 1. But also in RPN 1, to keep complexity low, there's only a single instance of Cerberus running at any one time, whereas in RPN 2 you can have many Cerberus instances running on the same machine in parallel with each other. So it's kind of like single-threaded versus multi-threaded. In RPN 1 it's single-threaded, in RPN 2 onwards it's massively multi-threaded. The complexity of multi-threaded right now is quite high, and obviously we want to get to market as quickly as possible. So that then predicates the requirement for, well, if we're going single-threaded, we can't have too many validators, because if all these validators, if we had, say, 1,000, then your message complexity and authentication complexity goes exponent, and you don't want exponents. So while it isn't the perfect situation in terms of decentralization for RPN 1, it does mean that we can get to market much quicker than if we were building RPN 2 as our first go-to-market strategy. But there is that trade-off of you need to keep the validator set low. So that will probably look or have some flavors of delegated proof of stake, but only for RPN 1.
Yeah, so I think the question is like minimum isn't that it has to have a minimum of 100. It's that we will be making sure that 100 there will be at least 100 validators allowed in RPN 1. But like if there was less than 100 validators that joined at the start to be validators, then it would still function with 20 validators. It's just that it's the maximum. We will allow a maximum, and our minimum maximum that we're aiming for is 100, if that makes sense. As in, like, it will be 100. It could be more, but we're pretty sure that it's going to be 100. But like, if it's less, then the network will still run. It's just you can't do any more than 100. And if you get to 100, then it starts getting to the point where delegation makes more sense, because then you're essentially competing to be in that 100.
Yeah, so there's a few stepping stones to get to RPN 1 to 2 and then 2 to 3. But I mean, it's going to be a young network. RPN 1 isn't going to need thousands of TPS. It's not gonna need to be super duper decentralized. I mean, they're nice things to have, sure, but we've got a roadmap to get to that. We've got a strategy to get there. So it's kind of, yeah, let's just get something out, get it running, test the kind of core fundamentals of the technology as well. If there are any problems, a single instance unsharded Cerberus is much easier to debug and fix than something that's multi-instance, which is also a nice thing about what Cerberus enables us to do, is kind of stage it and release these things with increasing complexity, but have the confidence that the stuff that those increasing complexity things build on top of is really, really solid. Instead of just trying to boil the ocean in one go, we can boil it a lake at a time.
Question: what is the situation on OTC? It's not something that we're commenting on in this AMA. Stupid question, probably, but I have a feeling that in RPN 3, shards might be attacked by malicious nodes pretty easily. If amount staked in these shards is quite low, close to threshold, is there such a danger? How does Cerberus protocol make life of a malicious node more difficult?
Whoa, yeah, this is a good question, and it's a question that needs about an hour in its own right for me to answer it absolutely completely. But I'll try and do a compressed 5-minute thing, and then, bro, if you want to, bring it up in the Telegram chats or any other kind of discussion forum and get a bit deeper into it afterwards, then we can do that. So RPN 3. The shards are more like they're ephemeral shards. So each particle essentially lives in its own shard. So for me to attack a particular shard, what I'm really doing is I'm just attacking a particular particle, and that particle might just be 5 rads. And then when the owner of those 5 rads spends that 5 rads, that shard is essentially dead, unless it's a collision, which is super low odds. But then if there was a collision 2 to the power of 256, if it happened, then that shard would kind of revive with a new particle in there. So for me to actually attack that particular shard, I've got to put my nodes, my validators, across that shard. And if I don't already know about a particle that's there that I wish to attack, and kind of store liveness on, because that's the only real thing I can do, is I can only really store liveness on that particular shard with that particle in. Then if I don't know, so like if I wanted to attack you, bro, but I didn't know where any of your particles were, or you made a transaction that changed the state of your particles or the particles that you owned, then I may have put some validators in a particular place, but in the meantime, you've spent some funds that has then changed which particles you have. And so therefore, you have a different set of shards that constitute your account. So I put all my stuff in the wrong place. Then I've got a destake. I've got a destake, which takes a period of time. I've got a restake in the new place, which takes a period of time. And then in the meantime, you then spent some more. And it's like, oh shit, he keeps moving these particles around, and I can't keep moving my validators because the length of time it takes me to do that. That's kind of the kind of simplest I can break it down for a quick 5-minute. Part of the reason why these shards and the Cerberus instances are ephemeral, so that stuff moves around, so that I can't easily go shard shopping, which is what we tend to call it, where I'm putting all my validators, all of my stake, all of my Sybil power in one place because I want to attack it at a particular thing. Now, if I'm successful, all I can really do is store liveness on that particular particle. So just because I can store liveness on that particular particle doesn't mean that I can store liveness on any of your other particles. So you could still represent your transaction with some different particles, and it will go through because I don't have validators on those other particle shards. Does that make sense, Piers? I felt like it kind of made sense. Did it make sense?
I mean, it makes sense because I've been following this for
right,
months,
exactly.
Right?
But then I'm kind of coming in a bit cold here with these guys. So yeah, if it didn't make sense, then somebody shout out, and I'll try and give a bit more of a concise explanation.
Cool. Can you give any comments regarding testing Cerberus at Expo Labs, quoting Mohammed Sadogi, words, it was part of their work and in real world environments?
I'm not sure where that quote's come from. I mean, has there been any quotes from Mo anywhere?
Yeah. He released a public statement about the Radix work. Cerberus represents a new generation of Cerberus. Cerberus represents a new generation of consensus protocols designed and built around a highly sharded data structure, enabling unprecedented levels of scale for a distributed ledger. We're excited to be testing Cerberus as part of our work at Expo Labs and see how it performs in real-world environments.
Okay. Was that? I'm guessing that was yesterday, right? When I was busy stripping the old office down and everything.
No, that was actually at the same time as we released the white paper itself. So we're going to be releasing some more details about our work with Mo. Basically, him and his team have put together a what essentially amounts to a specialty consensus testing bed that sort of is a combination of simulated real world environments, so Byzantine actors, faulty actors, like things going on and offline, with a sort of like a mathematical way of actually modeling systems. And so it's a very novel approach to going, right, we've got this novel consensus system, aka Cerberus. Let's put this into our test environment, which is like it's a step between actually deploying a system in the real world and at what you would consider like a traditional simulated environment, where it sort of goes further than that, but isn't quite all the way to sort of a real world
environment. Fuzz testing for consensus mechanisms. Do this, send that over there. Do this wrong, do that wrong. So if anyone's familiar with fuzz testing, like REST API or an API endpoint or something, it's kind of similar in the way that it's doing. It's just throwing things into the network that try and cause bad stuff to happen, and then sees how the network responds, if it crashes or goes down before the security bound that you would expect. So like if you needed 33%, but it failed at 20, then there's clearly something wrong somewhere, and all that kind of stuff. And UC Davis is an interesting partner for this, because for us to build those testing environments, it takes a long time, and for each consensus mechanism, you need to put a lot of time and effort into actually building your framework and then building the specific components that you need. And they've already got a lot of that done, and a lot of Cerberus just kind of very nicely slots into what they already have. So as well as getting eyes on from academics and professors and all their knowledge that they have, we also get to access their really good Expo Lab consensus testing framework as well, which should save us quite a bit of time.
Yeah, and like it was really interesting working with Mo on this. Like he was super excited about the Cerberus paper when we presented it to him, and was very like he was just like this is right at the cutting edge of everything that's in the consensus space right now, and was super excited to get his team working with us as soon as possible. So that was really great. And we know that academics move slowly. We know that this academic process is going to move slowly. I don't expect anything anytime in like the next couple of months, but it's great to have that going on in the background and really like adding the more certainty to what we already believe to be an incredibly robust approach to creating linear scalability in a decentralized environment. So some think you threw everything away from Radix and replaced it with established algorithms and concepts, etc., etc. Is it the case? What are the main benefits of Radix? Why is it still better?
Okay, so yeah, this comes up a bit as well. We really didn't throw that much away, to be honest. We still have all the Radix engine, all the composability stuff that we made there. There's a lot, like the Radix engine carries a lot of the application layer stuff that we need to be able to do in order to make Radix even successful. I mean, it's no good being able to do 1 million TPS if there's no way for anybody to use it. The shard model we spent a lot of time on the shard model and figuring out how to do state sharding. So all of that kind of knowledge and experience carries over, and the shard model of Cerberus and the state shard model of Cerberus is borrows a lot from Tempo, and I would even argue that it's an improvement, because there were lessons learned there, and with Tempo it was like, oh, we can't really improve that bit now because we've built all this stuff that relies on that piece. Whereas now it's like, well, this is a bit more of a clean slate. So these things we identified in the past that we could improve in our existing shard model from Tempo, we actually get a chance to do those now. So there's all the shard model stuff that's come over. We learned a lot of stuff around gossip, on how to do that very efficiently, because that's what Tempo required. We really needed efficient gossip, and efficient gossip is just good to have anyway. So we learned a lot of stuff there. Things like on how to do fault detection, which may come in useful, or probably will come in useful later on, to do with kind of stake slashing and stuff like that in the RPN 2 and 3 networks. Learned a lot there on how to kind of detect certain things, and how to make it so it's very difficult for nodes to not expose their malicious behavior. Other things that we're going to use here is like random verifiable random functions. We learned a number of ways to do that in with Tempo, and a lot of that can carry over as well. And then there's things like replaced it with established algorithms and concepts that I've seen a few times. And well, logical clocks were a established algorithm and concept, and Merkle trees that made up a lot of the Radix temporal proof was a established algorithm and concept. I mean, everybody builds mainly on the shoulders of giants and then adds their own little bits and pieces, and then somebody else comes along and builds on that collective shoulders of giants and does their own little thing, and then they become part of that collective, and so on and so on and so forth. So some things were thrown away, sure, but a lot of it wasn't. So yeah, same.
I think the answer to this, the what is the main benefits of Radix? It's what it's always been. Like, it's linear scalability of not just transactions but states for smart contracts. Like, this is something that is so critical for the industry that no one has a good solution for. Like, we're seeing what just happened with MakerDAO, and like the market crash and the congestion on Ethereum that has meant that people have walked away from collateralized contracts that should have covered, they should have seen a maximum loss of 13%, walking away with zero because of the congestion, because smart contracts don't scale and no one has those answers. And it's a combination of how we have created consensus scalability, but also how we've then put on things like the Radix engine on top of that to make that into something that's actually composable, actually can create these kind of functionalities in a way that does scale and can work for the world. So like, as
well, it's like, does the how really matter as long as you get there? Like, linear scale, state sharding, etc., etc., etc. Who cares how that's done? Right? Who cares really how it looks under the hood? No one's going to care how it does what it does, as long as it does it. And if as long as we achieve that, then I think the how isn't so much of a question, so long as it meets the why and it gives you the what. That was a bit cryptic, you know what I mean?
Yeah.
Trying to sound smart with the whys and the whats, and they ultimately failed.
I always wanted, I hope you guys are hammered down all your doors and windows and close yourself in a bunker while the virus is seeking for the next big system. Is everyone in the team okay? We have one potential COVID-19 victim in our team. He's fortunately young and healthy and should pull through okay. We are a mainly remote team. We're now, like, the London office is working from home. The Stoke office is also working from home. And the rest of the team is basically remote. We've got some people who are stranded in other countries at the moment, but fortunately, because we set ourselves up as a mainly remote working team, it hasn't impacted our work. We still do sort of our stand-ups and our we haven't really seen an impact on our productivity, so that's been good. But yeah, like, it really sucks. Really sucks for the world, and we're doing our part by trying to make sure that we're social distancing and not really sort of spreading it to
I'm
reduce
an
the
introvert anyway.
impact.
I'm always socially distant, so I'm okay.
Yeah, I'm in the COVID cave. You're in the COVID cave because of COVID-19. Yeah, I'm just in the COVID cave. Bouncing ideas around, is it a way of planting a paid streaming platform on top of Cerberus, some kind of paper by streaming? Yeah, absolutely. We played with some ideas like this. If you go on our blog, you can see a Radflix idea. This was the idea of owning rather than streaming, but you can see how that can quickly go to the sort of like the streaming section. Often I think for things like that, there's state channels are probably going to be a cheaper way of doing it than every single transaction on Ledger. But yeah, absolutely, you can do things like that. And if you want to build one of those, then we absolutely want to see it and play around with it. That would be awesome. Our ground was chosen to power Marshall Islands' national digital currency. Do you think Radix might be a choice one day too? Yeah, sure. We've spoken with a number of governments and organizations that are working with governments and building digital currencies. I think that the scalability, like for countries as small as the Marshall Islands, scalability is not really its issue, especially as the degree of digitalization of the country itself. So the degree to which the country is cashless, the degree to which transactions are not performed online, mean that these kind of like peripheral state currencies are going to have a lower impact to the overall economy, because you're going to need so much behavioral change in the economy itself before you can really take advantage of that. Countries like Singapore, like China, and sort of more high-tech countries, Sweden, and other members of the European Union are gonna get more impact from their choice of digital currency. Most of their platform that are choosing digital currency, most of the stuff is still in trial phasing. So like just working out what a specification needs to look like, what its performance needs to look like, and when Radix is at its later stages of development, and we have a public network available, we're absolutely going to be going after these kind of opportunities, armed with the knowledge that we've already built up from having these conversations before. Are you aware of the network of networks, Internet of Trust, being builded through Quanti network over Ledger blockchain Internet operating system? Ooh, that is a mouthful. And if so, how do you think Radix and them can enhance each other? I don't know what that project is. Do you know what that project is?
Never heard of it either. And I think I would definitely have remembered all of that. Yeah, I mean, is it worth looking at? I mean, I'm always trying to stay ahead of the curve, which is difficult sometimes. There's so much going on here at the moment. But then interoperability isn't really something that we're paying much attention to at the moment. I mean, it's nice in the future if that's something that we can do, but there's a lot of work in interoperability, and oh god, yeah, I'm losing my tongue already. There's a lot of work involved in that. I mean, there's been multiple attempts as well over the past decade with like different blockchains and stuff, and Polkadot's looking at some of that. There was one called was it BlockNet or something like 6 or 7 years ago. It was trying to do the same thing, and it's one of those things that sounds fairly simple at a high level, but once you get into the kind of low level detail, all these blockchains work slightly different. They all have different kind of multi-sig or like fraud proof systems and all this kind of stuff. It's really quite, you got to move a lot of bricks around in order to get it to go, operate properly and stuff like that.
There's also quite a lot of stuff around what is it that you're interoperating? Because this isn't like blockchains and DLTs are stores of value a lot of the time. They're places where an asset lives. And so, what does Bitcoin interoperability really mean? Or what does, Ethereum interoperability really mean when you're dealing with an asset that lives on that ledger? And so I'm not sure that this concept of interoperability is often sort of bandied around, but it seems to think about like the idea of messages being passed between ledgers.
It's
Or
protocol incompatibility, kind of.
right. Where like actually like the main things that really matter are the assets that live on these ledgers. And so your interoperability then comes into whether or not you're locking and unlocking assets in contracts on ledgers, and where the custody of those keys live and how they work on the different how those states are managed on the different ledgers. And I feel like we're further away from that than we think. There's some really interesting potential projects with stuff like the Ren protocol, where they are using Shamir secret, like sort of Shamir secret key sharing as a way of doing like of making sure that you can have a network that can essentially have custody of assets in different ledgers without any one computer being able to have ownership over the keys, and you just have a complicated mechanism of reconstructing those keys to authenticate transactions or submit transactions that are necessary. But I think like a lot of this seems a little early, feels a little early. We're talking about sort of interledger interoperability when we haven't really got to the point where we have like really good use cases for individual ledgers on their own at the moment. So like DeFi looks like a good starting point, and some other sort of like government currencies look like another good starting point. And there's a few other potentials, but like we're still very early in this journey. And like we're still in the intranet era, and when we get to the internet era, it's not going to look exactly like the movement from intranets to internet, because that was just a opening up of information protocols. Here we're talking about the opening up of value protocols, which have a whole host of other things that have to be thought about before we can actually get there. And I think most of the interoperability protocols sort of treat this as like, I want these things to be able to speak to each other, which isn't quite enough on its own without some substantial extra programming on all of those ledgers to make these sort of like inter-value contracts work as well, or some lots of extra sort of like cryptography work around how to securely custody like private keys without in a decentralized fashion. Like all of this stuff is still very much research based, and I think that a lot of it is a long way from being sort of ready for prime time.
Yeah, as well, like the interoperability thing, it's discussions I've had in various places with various people, various conferences and whatnot. And there's kind of this, one coin to rule them all will never happen. And I don't think that would, because it's a coin. And so you can move that value from one place to another, right? You can burn it here, or you can wrap it, or, you can transfer it onto a different protocol. But I definitely do think that there may be one protocol to rule them all, because when you have all this interoperability, it just gets really complicated, right? Like imagine if your browser and the internet was a bunch of different protocols. If I wanted to go to one particular website, I had to use one protocol. If I wanted to go to Google, I had to use a different one. If I wanted to go to Amazon, I had to use a different one. And your browser had to manage all of those protocols and kind of join them together, so that I could send an email in my Google email client to the person that I'd bought some stuff from on Amazon in that protocol. I mean, it just ends up being a mess. It just wouldn't happen. And so I do think that there's a definite chance there will be one main protocol. And there still are some other internet protocols. You've got the FTP stuff. FTP is still used. You've got your kind of SSH stuff as well, and all those kind of useful protocols. But back in the day, there was a lot of kind of contenders for the TCP/IP crown, and a lot of them did some things better than TCP/IP. But TCP/IP was so generalized and so minimalist and so simple that it ultimately won. But back in the 60s and 70s, they were, God, you can go on Wikipedia and find out all the different protocols that were competing for the main crown of data transmission between different networks and stuff. And protocols like Gopher as well, that's dead now, and all these other ones just aren't.
So I'm just gonna cut in here. We're gonna be cut off very shortly, so we should probably wrap it up. But thank you very much for everyone's questions, and yeah, looking forward to seeing everyone next time, and answering a few more questions about Radix. Yeah.
Ciao.
Cheers, guys.